Hello and welcome. In this video, you will learn the basics of Kotlin Coroutines framework in the context of a real Android application. Now, as you might have noticed, this video is not very short, to say the least, so let me explain you what it contains. Now, please take a moment to listen to this explanation because, first of all, it will help you calibrate your expectations, and more importantly, maybe you will realize that there are some parts that you can just skip in order to spare your time. And also we will discuss the tutorial application that you will need to clone locally in order to solve the exercises. So this video contains basically two parts. The first part is an introduction to concurrency in Android. I will explain what it contains in a moment. And the second part is coroutines basics in Android. So I will show you how to use coroutines in a real Android application. Now, introduction to concurrency in Android is basically the following. First of all, we will discuss so-called UI or main thread. You will understand why this thread is important and how you should use it. Then I will show you what happens when you overload this thread, this UI thread with work, when you try to basically execute too much stuff on this one single thread. And then we will discuss what concurrency is and why we need it. And lastly, we will discuss how you achieve concurrency using background threads, and I will show you actually how to do that using a bare thread class, something that most Android developers have never seen because everybody in Android world just use concurrency frameworks, but understanding how to use bare threads is crucially important. It will allow you to understand coroutines so much better. So this will be the first part of this video, and if you just read this list of topics and you think that you know everything, you can skip it. And then the second part is coroutines basics. We will discuss how to use coroutines framework for concurrent execution in Android application. We will discuss coroutines cancellation, and then a very important topic was the difference between suspending calls and blocking calls. And this will lead us to a very interesting topic, concurrency on UI thread. So as you might know, in blocking world, it's impossible to achieve, well, it's very difficult to achieve concurrency on one single thread. But if you use coroutines, then using suspending functions, you can achieve concurrency on one single thread. And in our case, that will be UI thread relatively easily. And then you will have 3 hands-on exercises. So in this video, I will ask you to do 3 different exercises, and they will allow you to practice concurrency, get intuition, and also touch all the basic building blocks of coroutines framework. Now, these exercises that you will need to solve, all of them are part of the tutorial application, and the source code of the tutorial application is on GitHub. You will find a link to this application in the description of this video. It's somewhere below here. So maybe before you proceed with this video, just go and clone this application to your local machine because you will need this application. You can just follow along, in the future parts of this video when I will be coding, you can just follow along and see everything inside your IDE, Android Studio, for example. And you will need this application to solve exercises because all the exercises are in the context of this code base. So go clone it right now. And lastly, let me explain to you why this video is so long and where it comes from. So this video is basically the first part of my full coroutines course. I decided to put this information on YouTube for free because I really think that all Android developers should understand what you will learn in this video. If by the end of this video you feel comfortable and you don't need anything else, well, great. But if you want to kind of dig deeper into coroutines framework and you want to understand the more advanced concepts, then you will find a link to the full course in the description to this video as well. Therefore, if you like this video and you find it useful, you might want to take a look at my full coroutines course, which contains more than 10 hours of very advanced discussion of concurrency and coroutines framework in Android applications. So, said all that, without further ado, let's jump into the coroutines world. Alright, let's right away jump into the source code. So I go to coroutines demonstrations UI thread, and here I have this UI thread demo fragment. Let's see what this fragment does. Well, it's relatively simple. It has just one single button, button start, and whenever this button is clicked, I basically disable this button, this same button, and execute benchmark. What kind of benchmark is this? Well, that's a very simple benchmark. All I do here is counting the number of iterations I can fit inside a specific time interval. And in this case, the benchmark duration in seconds is 5. In other words, this benchmark counts how many iterations can I fit into 5 seconds. However, before I execute this benchmark, I call to this update remaining time function. And what it does, well, it just prints remaining time, seconds remaining, and then schedules in 1 second a recursive call to itself. So every 1 second it will call to itself, but will also decrement this remaining time seconds by 1. So this function should basically print 5 and then 4, 3, 2, 1. It just shows the time remaining until the benchmark is completed. And then once this remaining time seconds becomes 0, it simply prints done. So once again, whenever I click on that button, I start updating remaining time. We have this txt remaining time. So basically we have some kind of a text on the screen. And then I execute this benchmark. And after the benchmark completes, I will show a toast that will basically just show the number of iterations count that my code could fit inside 5 seconds. Again, very simple benchmark. It doesn't do anything useful. I just want to show you something. So let's install this application and then run it. All right, let's go to UI thread demo and click on start benchmark. I remind you that according to my code, well, at least according to what I wanted to achieve when I wrote that code, whenever I click on this button, I should see the progress, basically the remaining time for this benchmark. Let's see if that's what will happen. Start benchmark, the button is stuck, nothing is printed, and then after 5 seconds, I see this printout of the number of iterations, and only then I see this count back. Once again, start benchmark, button is stuck. Now I will see this toast. And 3, 2, 1 seconds remaining. So for some reason, instead of what I wanted to achieve, instead of doing these things basically at the same time, running the benchmark and printing the remaining time, my code executes the benchmark. And while this benchmark is executed, the button is stuck, nothing is printed. And only after the benchmark is completed, I can see the printouts, and basically they're wrong because the benchmark has already completed, right? All in all, my code doesn't really do what I wanted it to do. So let's see what's the problem. I can investigate this problem using this log thread info calls. So basically that's a very simple function that whenever I call to it, will print this label and then print the information about the thread on which it executes. So basically it allows me to see on which thread the code executes at various points inside this flow. So let's open a logcat, and here I can see the following. For example, let's start from the beginning. Button callback, that's here. Basically, whenever I click on this button, thread name main, thread ID 2. So this callback executes on the main thread, also called UI thread. That's the most important thread in Android application, and everything related to the user interface executes on this thread. And by the way, you might be wondering what's actually a thread. Don't worry, you will not need to understand threads in much details right now, but you will gain more insights into this construct later in the course. So currently, let's call a thread some kind of a worker. Thread is something that can execute work. Currently, I'm using the main worker, and this button callback is called on this main worker. Okay. Then I see this update remaining time call. Where does it come from? Well, it comes from here, execute benchmark, and the very first thing that I do is calling this update remaining time. And here I have this log thread info. That's exactly this line. So update remaining time, 5 seconds remaining, right? That's what it says. And the thread name is again main and thread ID is 2. So basically this method is called on the same exact thread, which shouldn't be surprising to anyone because nowhere in my code I actually changed threads. And if I don't do that, the code that I write will just execute on the same exact thread. Alright, so I see that 5 seconds, basically the first invocation of this update remaining time was successful. And right after that, see 371.371, at the same time, right after that, basically, I see this benchmark started. That's this printout. So I executed this update remaining time function, and then immediately I executed this thing, and the benchmark started. The next printout, however, the next log statement comes 5 seconds later. Notice that's 12.371 and that's 17.372. So the next printout comes 5 seconds later. What happened in between? What happened in these 5 seconds? Well, my benchmark executed in these 5 seconds and then it completes. And it completes on the same main thread. And only then, after the benchmark completes, I see this additional printouts update remaining time 43210 seconds. And that's exactly what we saw in the application, right? We saw that I started benchmark, something stuck for 5 seconds, and then there were these printouts. We saw them. So basically, what happens here? Well, this main thread, main worker, can execute just one single task at a time. It can do just one single thing. Therefore, when I start the benchmark and this while loop gets executed until 5 seconds pass, main thread can't do anything else. So basically, main thread is stuck inside this loop for 5 seconds. It just increments this iterations count. And only after this loop completes, only then basically the main thread prints this thing, and then it becomes available for other code to run. What code is that? Well, that's this code. So basically, I posted something to this main handler. Again, we will talk about this handler a little bit later in the course. I posted something, post delayed, and I expected it to have a delay of 1 second, but instead between this invocation 5 seconds and the next invocation 4 seconds, see there's more than 5 seconds passed, even though I expected that to be just 1 single second. And the reason why it happened is because, well, my benchmark basically consumed the entire UI thread. And needless to say, that's not what I wanted to achieve. There's something inside this code that I need to change, and that will be introduction of concurrency. So in the next lecture, we will talk about what concurrency is. We concluded the previous lecture with the realization that the program that I wrote was buggy. And the reason it was buggy was because it attempted to execute several different tasks on one single thread. That thread was main or UI thread. So we need to change that program in some way, which will allow multiple tasks to execute kind of simultaneously. And that brings us to the topic of concurrency. So what's concurrency? Well, concurrent program is a program that has the following characteristics. Multiple tasks within a program which seem to be executed at the same time are said to be executed concurrently. So if I have multiple tasks and it looks like they are executed at the same time, these are concurrent tasks. And you might ask, wait a second, what does it mean seem to be executed? What does it mean seem to be? Are they executed at the same time or not? What are you trying to say? Well, the thing is that they can be executed at the same time. For example, if you have multiple cores within your CPU, then each of these cores can execute its own task. But they can also be executed concurrently on one single core. And in that mode of operation, basically that core will allocate short periods of time to each one of these tasks. So imagine that you have two tasks and each of them is executed for, let's say, half millisecond on that one single core. And then if you look at the state of the system after 1 millisecond, then, half millisecond and another task half millisecond, so 1 millisecond, then it will appear to you as an external observer as though these two tasks executed concurrently, simultaneously during that 1 millisecond. And really the distinction between these two modes of execution is irrelevant to Android developers. It's irrelevant to basically high-level application developers. It's only relevant if you need to go deeper into the technology stack, virtual machines, operating systems, etc. But we, application developers, we shouldn't be concerned about that. All we want to achieve is for a couple of tasks to kind of be executed at the same time, and we don't really care about how operating systems and virtual machines achieve that functionality. Now, next, concurrent tasks can be completely independent. So imagine that I can fire multiple tasks. Let's say I need to produce multiple reports. I can fire all these tasks, and these reports will be produced without any dependency between them. So, for example, one report can be produced within a minute, and a more complex report might be produced in an hour, and these tasks are not dependent upon one another. Or these concurrent tasks, they can have interdependencies which establish specific ordering rules between them. And for example, imagine that you need to download a couple of files from the internet and then play them in some kind of media player. Well, then you will have basically multiple concurrent tasks, each of them downloading files. And then all these tasks will, basically not all these tasks, but there will be one additional task that waits for all these downloads to complete. And once they complete, it will basically play the multimedia within this media player. So that's kind of ordering between different concurrent tasks. We will get much more deeper into all these aspects in this course, so it's totally alright if you don't understand it right now. Just remember that basically concurrency is when multiple tasks seem to be executed at the same time. That's basically the most important part right now. That said, I want to warn you. Even though currently we are discussing concurrency at a very kind of intuitive level, in practice, concurrency is one of the most challenging topics in software and hardware development. So concurrency is fundamentally complex, it's challenging, it has many edge cases, and really concurrency bugs are among the most serious, the most severe bugs that a program can have. So therefore, just don't relax too much. I will kind of take you step by step, and I will explain you anything you need to know in the context of this course about concurrency, but just remember that concurrency is very difficult and it's a tricky subject. Okay, now this course is about coroutines, and now we talk about concurrency. So what's the relation between these two subjects? Well, coroutines is a framework used to introduce concurrency into Kotlin applications. So if you write Kotlin code and you want to introduce concurrency, you want multiple tasks to be executed at the same time, then you can use coroutines framework for that. And that's basically what this course is about, how to use coroutines to introduce concurrency into your Kotlin application. However, we will deal with coroutines a lot, but in general, okay, my goal in this course is to provide you with the minimum amount of theory required to make an efficient use of coroutines in your applications. So it is not my goal in this course to cover the fundamentals of concurrency and basically explain you everything it is to know about concurrency. I actually have a course like that, and I already know that if I would attempt to do that in this course, it would make it 5 hours longer. Instead, what I want to do is to explain you the concepts of concurrency, which are directly related to coroutines. Therefore, by the end of this course, you will understand how to use coroutines, but just keep in mind that you will not know everything it is to know about concurrency. And once again, the reason why I don't want to get down this rabbit hole is because I know that it immediately adds about 5 hours to this course. And really, I want to make it practical so you can kind of learn coroutines and use them efficiently in your Android apps. So, keeping all these disclaimers in mind, now that you understand what concurrency is, at least intuitively, and you understand that coroutines is a framework that you use to introduce concurrency into your applications, let's get back to my kind of UI thread demonstration and fix the problem that I demonstrated in the previous lecture. At this point, you understand that I need concurrency in order to fix that issue that I showed you in the very first lecture in this section. And you also know that in order to introduce concurrency in Kotlin, I need coroutines. However, a moment before we jump into coroutines, I want to show you how to achieve the same goal using bare thread class. Now, that's not something that you should do in Kotlin. However, that said, I think that seeing how to introduce concurrency using threads will help you, will give you some intuition about the lower level implementation of concurrency in basically Kotlin, because Kotlin, you know, on JVM, on Java Virtual Machine, Kotlin still wraps Java primitives. So Kotlin still uses threads, and coroutines use threads under the hood. And therefore, understanding how to use bare threads, at least intuitively, will allow you to grasp coroutines much easier in the future. So I introduced this background thread demo fragment, and currently this fragment is exactly equivalent to this UI thread demo fragment that you already saw. And currently I want to introduce concurrency using thread class into this fragment in order to achieve the result that I wanted. So let's understand where the concurrency should come into the play. Well, this execute benchmark method contains this while loop, which executes, well, the benchmark. And as we saw, when this benchmark is executed, UI thread, main thread is blocked and can't do anything. That's not something that we want to have in our applications. Therefore, this part of the code should execute concurrently with anything else that happens inside the application. So this part of the code should be moved to a new thread. How do we do that? Well, relatively simple. I will just create a new thread class, and the constructor of thread takes in one single runnable. And I can use this SAM convention to basically avoid explicitly declaring runnable. And whatever I put inside this runnable, inside this block of code, will be executed on a new thread. So I will just take that, okay, I will take that and move it here. And by the way, I shall also take this part. So basically, I call this update remaining time on a main thread still, but then I introduce this new thread and execute benchmark there. However, this new thread will not start after I just construct it, so I should explicitly call start on it. Now it will run, and of course I need to take this toast and put it here as well, because iterations count variable will not be available outside of this thread. And lastly, Android Studio gives me a hint, move lambda. Yes, I can even do it like this, so I don't need this parenthesis at all. Again, why did I do that? Well, simple. Create a new thread class, call its start method, and then inside the runnable that I pass into its constructor, put this code that executes the benchmark. And that's really all. Let's see what's the result of this transformation. I go to background thread demo, and then I click on start benchmark. And you see that I see this countdown right away. The button is not stuck, but then my application simply crashes. What's going on here? Well, let's see the logcat. The exception that crashed my app is this: runtime exception can't toast on a thread that has not called looper prepare. What does it mean? Well, it means a lot of things, but basically, as you might already know, anything related to user interface in Android should be performed on the UI, on the main thread exclusively. However, in this case here, I call this toast make text method on a background thread, on this worker thread that I created right here. And therefore Android crashes my app saying, sorry pal, you shouldn't do that from a background thread. That's the problem. To address this problem, I need to move this toast make text show code back to UI thread. However, I cannot just put it right here. Well, first of all, I can't access iterations count, but let's say I will make it work. It still won't work as I expect it to work because there is a concurrency here, remember? So whenever this update remaining time is executed, the next thing will be to create and start this thread. And then concurrently with the execution of this code, the next line of code will be executed on UI thread. So basically this toast make text, if I leave it here, will be executed before the benchmark completes, and that's not something that I want to achieve. So I should really put it right here inside this background thread in order to make sure that it will be called only after I perform this computation, this counting of iterations. But I should move it off the background thread back to UI thread. And the way to do that is what you see right here. I need to create a new handler and pass it main looper. It doesn't really matter what main looper is, just treat it as some kind of pattern that you should use. And this handler, when I post anything to it, that code will be executed on UI thread. And that's what I need in this case. So handler and then looper get main looper. And then I call post, just post in this case, because I don't need any kind of a delay. So let's make it like this and just move this toast into here. So again, what will happen? On the background thread, I will execute my benchmark, and then I will delegate the execution of this call to a main thread, back to main thread. And therefore, this should fix my problem. So let's rerun the application. Again, background thread demo, I will click on start benchmark. Note that the button is not stuck anymore. The countdown starts right away. And when the countdown will reach 0, I will see a toast showing the total number of iterations here at the bottom. So start benchmark, countdown, and boom, a toast. So now the code works exactly as I expected it to work. So let's jump into the source code just for the last time and go over what I did. The entire change that made my code work is restricted to this execute benchmark method. All I did here was to create a new thread and start it. And inside this thread, basically inside the runnable that I pass as a constructor argument into this newly created thread, I execute this code that, well, that's the benchmark itself. And then when the benchmark completes, I delegate this toast message back to UI thread. And that's because I should not touch anything UI related in Android on any thread except the UI thread. So that's why I need this handler looper get main looper and post this code to it. So as you see, code-wise, it wasn't that big of a change. And maybe lastly, let's jump back into the logcat and just see the printouts that we get right now. So we have this update remaining time 0, not here, button callback, thread name, main thread ID 2. So that's when I clicked on this button. And then we have update remaining time. So we enter this function, update remaining time, 5 seconds. And then we have benchmark started, thread name, thread 2, thread ID, something different. So this code already executed on a different thread, and that's not surprising because, well, that's what I did here. I created a new thread and I started it. Therefore, this code, this benchmark, executes on a different thread, and concurrently, see, this benchmark runs now on this thread ID 731, basically thread 2. And concurrently with the benchmark, I see these printouts that tell me 4, 3, 2, 1 seconds remaining. And then benchmark completes basically approximately at the same time. See, 16466 benchmark completes, and at 6530 I see this printout of 0 seconds left. So that's exactly the functionality that I wanted to achieve here. And all I had to do was to use a new background thread. I created this new thread, and any thread in Android which is not UI thread is called background thread. That's just a convention. So I created a new background thread and I executed benchmark on a background thread. And then at the end, I posted the results back to UI thread to show a toast. So that's handler get main looper, treat it as a pattern just to get a main handler or UI handler to post something back to UI thread, and that's what I do right here. And all in all, that's the way you use bare thread class to introduce concurrency into your application. In the next lecture, I will show you how to achieve the same objective using Kotlin Coroutines, and you will be able to appreciate the simplicity and the readability of the resulting code compared to what you see now on your screen. At this point, you've got some amount of intuition about multi-threading in Android applications, at least in the context of, let's call it, legacy Java multi-threading using bare threads. So now let's jump into Kotlin world and actually get to the point of this course, Kotlin Coroutines. So I created this basic coroutines package in demonstrations, and here I have this basic coroutines demo fragment. Currently, this fragment is an exact copy of UI thread demo fragment. So if I run the application, go into basic coroutines demo screen, click on this button, I will see it stuck and nothing is printed. After 5 seconds, I will see this toast and the countdown. So that's exactly the same implementation that I've had before. And now I would like to fix this program, fix this application using Kotlin Coroutines. Now, let me warn you right away. I'm going to introduce several very difficult and complex concepts all at once, because that's what coroutines require. And I don't expect you, and you shouldn't expect yourself, to understand these concepts right away. All of them are very deep and very complex. I will try to explain kind of intuitively what they do and why you need them, but please don't try to kind of build the entire picture in your mind. That will be a little bit too advanced for you at this point and will distract you from the most important thing that I want to give you in this section, which is intuition. So, said all that, let's start coding in coroutines. The first thing I will need is a coroutines scope. So val, let's make it private val, coroutines scope, and this will be just new coroutine scope. And now I will pass something called dispatcher as a context. So this will be dispatchers.main.immediate. Now, again, you don't need to understand what's coroutine scope, and you don't need to understand what dispatchers are, but intuitively coroutine scope is kind of a box for coroutines, and dispatchers is something akin to the threads. So basically this dispatchers main refers to the main thread, the UI thread of Android application. At this point, that's what I want you to understand about coroutine scope and dispatchers. So let's go into execute benchmark method, and I remind you that I want to put this benchmark, this code, to run on a background thread. How do I do that with coroutines? Well, I do the following. I grab my coroutine scope and call to launch method. Now, this launch function basically launches a new coroutine. So that's so-called coroutine builder. That's the way you create new coroutines. And now, since I want this code to execute on a background thread, I will pass in dispatcher's default. So this dispatcher's default basically offloads the work to a background thread. You will see that in a minute. Now, after I did that, I will grab this code, that's the benchmark, and put it inside this block of code, basically inside this new launched coroutine. And now I need to deal with this iterations count stuff. So just like before, just like I did with threads, I can just put it right here, and then let's run my application and see what's going on. Again, go to basic coroutines demo, click on the button, it's not stuck, I can see this countdown, but then boom, application crashed. And the exception that was thrown is exactly the same exception that you've already seen, right? A runtime exception can't toast on a thread that has not called looper prepare. And if I go and see what kind of info was logged, I can see that this benchmark started on this default dispatcher worker 1 thread. So basically, I did manage to transfer the execution of my benchmark of UI thread to a background thread, but this code is also called on a background thread, and that's not something that you want to do in Android. In Android, anything UI related should happen on UI thread. So how do I transfer the execution back to UI thread if I use coroutines? Well, it's really simple. I need to call this with context function and pass in the respective dispatcher. And in this case, this will be dispatcher main immediate. So grab that and just pass it here. Let's rerun the application. Basic coroutines demo, start benchmark, countdown, and when it's completed, boom, I see the toast and done is printed. So now everything actually works exactly like I want it to work, and therefore I fixed my code. Outstanding. Let's quickly go over what I did. Well, I created this coroutine scope, and as I told you at this point, just treat it as a box for coroutines. And this coroutine scope runs on dispatcher's main by default. And dispatcher's main is something related to Android's UI thread. So that's something that allows me to execute code on UI thread. And then inside execute benchmark, I launch a new coroutine. But since this coroutine, since this code needs to be executed on a background thread, I pass in a default dispatcher default. And this dispatcher default runs code on a background thread. You can see it right there, right? Default dispatcher worker 1. That's not main thread. Therefore, this code executes on a background thread, which is great. But then once my benchmark completes, I want to return the execution back to UI thread. And for that, I call to this with context function and pass in again dispatcher's main immediate to make sure that this piece of code, this toast, is executed on UI thread. And if you just look at this code, it's very similar to what I wrote with threads, right? So I remind you that in background thread, I created a new thread, and here I delegated to handler looper get main looper. And currently my coroutines code looks approximately the same, except for I have this coroutine scope stuff, which again we will discuss in much more details later. But except for that, this code is very similar. So are coroutines just replacement for threads? Well, not exactly. Coroutines allow us to do much more than standard threads do. And this code that I currently wrote, I wrote it intentionally to show you a similarity to threads. But now I want to basically leverage more goodies from coroutines to make this code even better and simpler. So first of all, I don't want to launch my coroutine right here. Instead, what I want to do using coroutines conventions is to turn this execute benchmark function into suspending function. And for that, I simply add this suspend keyword. And once I did that, please note that two things changed. First of all, I have this sign on this execute benchmark function. Whenever I call it now, Android Studio will add this sign, and also my code won't compile because it says suspend function should be called only from a coroutine or another suspend function. So that's what suspend functions do. They're kind of part of coroutines conventions, and whenever you designate a function as suspending function, you should either call it from coroutine or from another suspending function, and Android Studio designates suspending functions with this small sign in order to make it easier for you to identify them when you read your code. Now, what does it mean that I need to execute, basically to call suspending function only from a coroutine? Well, it means that I need to move this call, creating and launching a new coroutine, outside of this function. So I will do here coroutine scope dot launch and then execute benchmark. All right. And once I did that, I can basically remove this call from here. Let's just restore the source code just like it used to be before I introduced these additional constructs. Okay, so we are back to the original form of this code, right? And currently I launched this new coroutine, and you might ask, well, but what do you mean launch? Before that, you specified dispatcher. On which dispatcher will this coroutine be launched? And the answer is it will be launched on the default dispatcher for the scope. And here I designated that this scope has main dispatcher as the default. Therefore, this coroutine will be launched on the main thread, and everything inside this execute benchmark method will also be executed on the main thread. And since I removed everything from here, except for making this function suspend function, we are back to our bad situation. Let me show you that. So basic coroutines demo, start benchmark, the button is stuck, nothing is printed. I see the toast now, and then the countdown begins. So we are back to exactly the same bad situation that we had before, but now with coroutines. And that's the first very important point that you need to understand. Whenever you make a function suspending, it does not add any more magic. All this keyword does is basically instructing the compiler that this function is now part of kind of coroutines code, and therefore it should either be called from a coroutine or another suspending function. So that's a very important point to understand, that suspend keyword doesn't change the functionality of your code in the least. But now I actually want to fix this code. So I launched a new coroutine and it executes on UI thread, on the main thread, and therefore this entire piece of code is executed on the UI thread. That's not what I want. I want to switch this part to be executed on background thread. And for that, I once again use this with context function. And you might notice that Android Studio added this sign, which means that with context is yet another suspending function. And the role of this function, what it does, is allowing me to change the execution nature of the code. And in this case, I want to execute the code inside this block on this default dispatcher's default. I remind you, this means a background execution. Grab all of that and put it here. And just like before, after this code completes, I can do once again with context dispatchers.main.immediate, and then I can just put this code here. Let's run the application and make sure that everything works now. Basic coroutines demo, start. Nope, application crashed. Let me see what's the problem. Code from wrong thread exception. Only the original thread that created a view hierarchy can touch its views. What's the problem? Where did I touch the view? Ah, I see. Okay. So I put too much into this with context dispatcher's default. This code should be executed on UI thread. That was just copy pasting mistake. And this update remaining time should be called on UI thread because it's not part of the benchmark. The benchmark is this. So let's run the code again. basic coroutines demo, start benchmark, I see the countdown, and by the end of it I should see this toast. Yep, and done. Everything is kosher now. So that's another way to use coroutines with this suspending function, but you can legitimately say, Vasily, but you did not make this code any simpler right now. It still uses this with context and another with context and dispatcher's default, dispatcher's main immediate, even though this coroutine runs on this dispatcher's main immediate by default. Why do you need to reference it once again here? It's not clear what are the benefits of this code. And yes, if you think that you're absolutely correct, but I'm still not done. There are more conventions inside coroutines framework which will allow me to simplify this code. And really the very first thing that I want to do is to get rid of this with context call. Now, I need this with context to transfer the execution back to the main thread. I remind you that if I would use bare threads, I couldn't put this call right here outside of a background execution because that would happen concurrently. But with coroutines, I can actually do that. And this with context suspending function can actually return a result. So I can do the following: val iterations count equals whatever with context returns. And currently it does not return anything. So let's make it return this iterations count. Okay, and once I obtained this iterations count from with context, I can print it right here. And let me show you that it actually works. So basic coroutines demo, start benchmark, 5, 4, 3, 2, 1. And then we will see this toast here. Yep, and done. So this approach of returning something from with context call and then using it on the main thread actually works. And that's the first and maybe the most important difference between coroutines and threads. If I would go to this background thread demo fragment, there's no way I could return anything from this thread and use it right here. Therefore, I had to put this call inside this new thread. Yes, I delegated it back to UI thread, but I had to put it inside this block of code because there is no, well, at least there's no simple way for me to wait for the completion of this thread to print that. And actually, there's no simple way for me to pass the result of this benchmark outside of the scope of this thread. And therefore, I had to put this code inside the thread itself. With coroutines, it's different. Here, I can execute code on a background thread using this dispatcher's default and with context suspending function, and then just return something from this block of code and iterations count and use it right here. And it turns out that this assignment will wait for the execution of this entire block of code. It will assign the result into this new variable iterations count, and then the next line of code right here will be executed on the same dispatcher that I used initially. So I remind you that this execute benchmark is called from this newly created coroutine, and this newly created coroutine uses the default dispatcher specified for coroutine scope, which is dispatcher's main immediate. Therefore, this line of code will be executed on the UI thread after the execution of this block of code. So that's maybe one of the most important aspects of coroutines framework, that suspending functions are actually kind of waitable. So you can wait for the completion of a suspending function, in this case with context, and then the next line of code will be executed only after it completes. And this code can be executed on completely different thread than the one I use right here inside. So that's really cool, and it simplified the code a little bit, but still this code is not idiomatic. Why is that? Well, see, this toast make text should be called on UI thread. We know that already. And therefore, the fact that it resides here inside this execute benchmark function means that I assume in the implementation of this function that it will be called on basically main dispatcher, which means that this code will run on the main or UI thread of your Android application. That's the assumption here. Otherwise, if I call to this execute benchmark on any other dispatcher other than main, we will see that crash that we have already seen multiple times. And these kind of assumptions, when you write your code with these kind of assumptions, they're very bad because they're very difficult to enforce in the long term. So what can I do about that? What can I do to make sure that I can call this execute benchmark on any thread and it will work? Well, I need to take this line of code and put it outside of this function. But now I run into a problem. Okay, first of all, that's a suspending function, and whatever happens inside the next line of code, I remind you, that's the most important basically functionality of coroutines, the most important feature of coroutines, that this line of code will be executed only after this one completes. So coroutines will wait for the execution of the suspending function, and only then this line of code will be executed. But I still need to have a reference. Basically, I still need to somehow pass iterations count outside of this method to make use of this variable right here. And there's a very simple way to do that, right? Instead of assigning a variable, I can just do, okay, return, and then I will just need to make sure that I specify the return type in the signature of this function. So execute benchmark now returns long, and therefore I can use it here. And then I can do the following: val iterations count equals that, or I can just call this iteration execute benchmark right here, but I don't like doing that. Okay, I like doing it this way. So just to make sure I didn't break anything with this refactoring, let's execute the application once again. Let's run it. Go to basic coroutines demo, start benchmark. We can see this countdown and then a toast. Boom, everything works. And now at this point, I really use coroutines in a very idiomatic way, and you can actually see the benefits of this framework over threads. I can write a very simple code. Here I just launch this new coroutine and I tell it, okay, execute this benchmark. And we know that this benchmark should be executed on a background thread, but I don't care about that right here. I treat it just like a regular function. Okay, I assign the result into this variable, and then on the next line, I can just use it. And since this coroutine scope is executed on this dispatcher's main immediate, basically on the UI thread, I can be sure that this line will be executed on Android's UI thread. And whatever happens inside this execute benchmark, however long it will take to execute this method, this line of code will wait for that. That's what coroutines do. That's the main feature of coroutines framework, this kind of waiting for execution of suspending functions. So the code right here in this on-click listener became very explicit. Okay, I execute benchmark and I make a toast with the result, even though the benchmark itself is executed on the background thread. And inside this function, the code is also very clear, right? I initialize some variable, call that, and this will be called on the main thread. I will get back to that in 1 second. And then I transfer the execution to a background thread using this very simple with context dispatcher's default call, okay? And then everything here executes on a background thread and I return the result. And the result will be returned from this execute benchmark method. And once again, sorry that I repeat that maybe for the 5th time right now, but this line of code will wait for the execution of this function because that's a suspending function. Whatever happens inside it, we don't see it from here. Okay, it can be executed entirely on the UI thread, or it can involve tens of different threads that execute very complex algorithms. Whatever happens inside this function, this line of code will wait for all of that to complete. That's very important, okay? That's the most important feature of coroutines framework. That's why everybody is crazy about it. And once again, you might not see that right now, but we will discuss later more complex examples and you will see how powerful this feature is. And one thing you might be wondering now is the presence of this update remaining time method inside execute benchmark method. I told you when this line of code resided inside this method that it's a bad practice to assume anything about the thread on which this suspending function will be called, basically a dispatcher, which will be used to call this execute benchmark function. You shouldn't assume anything about it. But this update remaining time should be called on UI thread, because here right away I manipulate my user interface, and that's something that should be done on the UI thread exclusively. So theoretically, I should just take everything out of here, put it here inside this coroutine, and then maybe just make this benchmark duration in seconds an argument of execute benchmark method. And now it becomes even simpler. See, it just has this switch to a background thread, right? Using this with context, I switch to a background thread and perform this execution. Everything related to UI thread is now resides here. And the code became even better. However, I want to actually put it back inside execute benchmark. And the reason why I want to put it back here is because later, at a later point, I will use the fact that I called this update remaining time function from within this execute benchmark to show you additional stuff. So just to recap, when you write your suspending functions like this execute benchmark, you should not assume anything about the dispatcher on which it will be called. However, in this specific case, right here, this update remaining time function actually assumes that. It assumes that it will be called on UI thread, otherwise my application will crash. I know about that, that's non-optimal, and the only reason I leave it here is because later I will use it to show you some additional conventions of Kotlin Coroutines. All in all, I'm sure that you have many questions and you don't see the entire picture. For instance, we didn't discuss what coroutine scope is in details. You don't know what dispatchers are, except for main somehow corresponds to UI thread and default somehow corresponds to a background thread. And we haven't really discussed how exactly coroutines work, why this suspending function will wait, and what it means that here I don't need to care about what exactly happens inside this execute benchmark, and then everything will be just executed on the UI thread magically, and I don't need to take care of basically transferring the execution from background thread back to UI thread like I did with manual threading. So these are all very important and interesting questions, and we will address them later in this course. At this point, I just want you to have a bit of intuition about coroutines and actually see all these constructs in action, even though you still don't fully understand what they actually do. So this completes this lecture, and welcome to the coroutines world. In the previous lecture, I made a mistake in the way I use coroutines, so I would like to fix that mistake in this lecture. And really, it wouldn't be that hard for me to go back and just re-record the previous lecture, but I think that these mistakes allow me to explain to you some more concepts, provide you with more intuition, and after all, also show you that when we deal with concurrency, everybody does mistakes. Concurrency mistakes are something that you will do no matter how proficient you are with concurrency. That's why I say that concurrency is one of the most challenging topics. It's just difficult. So let me show you what I did wrong in the previous lecture. First of all, let's relaunch the application and see how it works. Alright, go to basic coroutines demo and I'll click on this start benchmark. And what I want you to notice is that this button, it doesn't become disabled. Okay, start benchmark, and it's still enabled. I can click on it. And then we see this very strange artifact that basically two benchmarks execute concurrently. And that's of course not something that I wanted to achieve. So let's get back to code. Inside the source code, right here, when this button start is clicked, I disable it, and then I launch a new coroutine, and then I enable it right here. So what I wanted to achieve here is to disable this button while benchmark is executed to prevent multiple benchmarks from being carried out simultaneously. Exactly the scenario that you saw right now. But currently doesn't work. This button is not disabled. Why is that? Well, that's the mistake that I did in the previous lecture. So here I launch this coroutine, and as I told you, this toast will wait for the execution of this method. Basically, that's the most important property of coroutines. However, whenever I launch a new coroutine, it will execute concurrently with the rest of the code. So this statement where I enable this button start back will not actually wait for the completion of this launch method. It has no correlation to it. It will execute concurrently with whatever it is that I perform inside this coroutine. So what really happens here is that I disable the button and launch a new coroutine. Inside this coroutine, I execute the benchmark, and then concurrently with execution of the benchmark, I enable this button back. And that's why, while this benchmark is being executed, I can already start clicking on this button start, and then I will get this very strange behavior that you saw. How can I fix that? Well, what I want to achieve here is to make sure that this button is enabled only after the benchmark completes. And to do that, I need to use this property, the most important property of coroutines, that inside the coroutine, the execution will wait for the completion of this suspending function. So basically, if I just take this statement and move it from outside of coroutine, from the general context, into the context of my newly launched coroutine, this will work. And by the way, it doesn't matter, but I want to put this statement here as well. And this way I can see that this coroutine is basically a kind of an atomic piece of functionality. I disable this button, execute benchmark, show toast, and then enable this button back. And let me show you that now it will actually work in exactly that manner that I intended it to work. The button will be disabled for the entire duration of the benchmark. Back to basic coroutines demo, click on start benchmark, and please note that the button becomes disabled. So I cannot click on it while this benchmark is executed. Therefore, only one benchmark will be able to run at any given instant of time, and I will not get these very strange effects that you saw at the beginning of this lecture. So once again, it's very important to remember that this property of coroutines that we discussed, the most important basically property of coroutines, that whatever it is inside coroutine will wait for the completion of a suspending function call, it only applies for the code that runs inside the scope of that coroutine. So basically here I launch a new coroutine, and all this code kind of behaves according to coroutine's conventions. But if I take this line and just put it outside of the scope of this coroutine, then I will launch this new coroutine, and then immediately on the UI thread, I will execute this call, and therefore this button will become enabled during the execution of the benchmark, and that's not what I wanted. So that was the mistake I made in the previous lecture, and I'm actually glad that I did it, because hopefully it allowed you to get a little bit more insight and a little bit more intuition about working with coroutines. As I already told you, exercises, hands-on exercises, will be a very important part of this course. And at this point, it's your turn to work. So, welcome to exercise number 1. To find the source code for this exercise, you need to go to exercises package, exercise 1, and here you will have two classes. One is exercise 1 fragment, and another one is get reputation endpoint. So what's this fragment? Well, it's very simple. You have this edit text, user ID, and whenever text on this edit text changes, you basically check whether it's null or empty. If it is indeed null or empty, we disable this button, and if it is not, we enable it. Whenever this button is clicked, I show this, basically I log this button callback stuff, and then I disable button, get reputation for the user, and the user ID is that thing that I enter inside this user ID edit text, and then I enable this button back. Now let's review the implementation of get reputation for user function. It's really simple. Again, log something and then call a method on this get reputation endpoint, and once I get reputation from it, just show a toast with this reputation. Really simple. And you might wonder what's the implementation of this get reputation endpoint, and in general it doesn't matter. It doesn't really go over the internet. It's kind of a fake object. What I do here is just log this thing and then sleep for 3 seconds, log this message, return data, and then just return some random integer from 0 to 100. So irrespective of the user ID that you pass into this method, you will get back after 3 seconds an integer in the range from 0 to 100. And this get reputation endpoint kind of simulates going over network, fetching something from a remote server. And again, the exact implementation of get reputation function is not that important. So let me run the application and show you how it works right now. I go to exercise 1 screen, the button is disabled, so I need to actually input something, and it doesn't really matter what I input here, but this thing will be considered user ID. I click on get reputation, the button is stuck, and after 3 seconds, I see this toast down here, reputation, blah, blah, blah. Once again, some kind of a user ID, click on this button, everything is stuck. You see, even keyboard is not hidden. And after 3 seconds, I will see this toast. So that's evidently not something good. That's a bad user experience. Your goal in exercise number 1 is to fix this bad user experience using coroutines. Now, I hear you scream, Vasily, wait a second, but you haven't explained coroutines yet. You just showed us some kind of an intuitive explanation, and we don't know what coroutine scope is and what dispatchers are. Yes, all that is true. But in this exercise, your goal is to basically get hands-on intuition with coroutines. So you don't really need to understand what coroutines constructs do. You can just go to demonstration, basic coroutines package, open this basic coroutines demo fragment, and then inside this fragment you'll have all these constructs that I demonstrated in the previous lectures. So just copy paste this code into exercise 1 fragment to make it work, to basically offload this get reputation for user call, offload this call basically to a background thread, and make sure that everything executes smoothly and you don't have a hanging user interface in your app. And again, you don't really need to understand what you actually do at this point. Just copy paste all these constructs and gain some hands-on intuition about coroutines. And in the next lecture, by the way, I will show you how to solve this exercise. So if you will have any difficulties, you can just skip to the next lecture and see how I solve it. Just a moment before you jump into exercise number 1, let me show you how I suggest you approach working with exercises in the context of Git. So if you do git log inside your repository, you will see many commits. Currently I have just these commits, but by the time you will clone this application, the entire source code will already be there, so there will be much more content right here. The first thing I suggest you do is switching to a new Git branch. To do that, you will execute the following command: git checkout -b, and then you need to name this newly created branch, and in my case I will name it my exercise 1. Name it whatever you want. and then Git will tell you switch to new branch, my exercise 1. So if you do git branch now, you will see that you have master branch and my exercise 1, and this asterisk means that you are currently on this my exercise 1 branch. And once you're on this branch, you do once again git log. You will have much more commits that you see right now on your screen, but you will need to just search inside git log to find this exercise 1 stuff. And once you found it, you need to copy this SHA identifier. That's basically a unique identifier of this specific commit. And then you can do git, let me just show it like this, git reset -- hard, and then you put this SHA identifier that you've just copied. And this will reset your local branch, this branch that you are on. So git branch my exercise 1. This will reset the state of my exercise 1 branch basically to this specific commit. Head is now at exercise 1. And now if you will do git log after that, you will basically see exactly the same commits that I see on my screen. And then you will jump into the source code, you will perform the exercise, add the required code, test it, and then once you achieved the desired functionality, you will do git commit -m and my solution of exercise 1, for example. And currently it says nothing to commit, working tree clean, but if you will have any changes, it will actually commit these changes. And once you'll do that, you can basically get back to the master branch to continue with this course. So you will do git checkout, and this time you don't specify -b because -b creates a new branch, but you just want to switch to another branch, and you just write this git checkout master, and then you switched back to master branch, so you are back in the original state of the repository, and you will continue with this course. So that's the way I suggest you work with Git when solving exercises, and therefore by the end of this course you will have Git branch, you will have a master branch, and maybe some additional branches that I might add in the following lectures, and you will also have all these my exercise 1, 2, 3, etc. branches, so you will always be able to go and see your solutions, and if needed, compare your solutions to my solutions as well. And by the way, I use Git through command line almost exclusively, but you don't have to do that. So if you are more accustomed to using Git from, let's say, Android Studio or some external Git client like SourceTree, then, well, be my guest. Use Git in whatever way that suits you the best. I prefer to work with Git in command line, but you don't have to do that. So good luck with exercise number 1 and have fun. Let me show you how I solve exercise number 1. So first of all, I will create here a new package, call it solutions. And then, well, let's just take this and copy paste it into solutions. So here I have exercise 1 fragment and get reputation endpoint. Let me rename that into exercise. Yep, I want exercise 1 solution fragment. So I will have this and coroutines, that will be solutions. Just fix that. Coroutines solutions exercise 1. Yep, that's. And then get reputation endpoint. I need to basically just import this, right? Exercise, no, not this. I want to use this one. What's the problem? Okay, again. Change, yes. And then, yep, and then we'll be able to use it. Okay, so I have this exercise 1 solution fragment, and I want to fix that. So first of all, I will create here a new private val coroutine scope. This will be a new coroutine scope. And then inside context, I pass dispatchers.main.immediate. Again, you don't need to understand much about this scope or about the dispatchers. That's kind of a box for coroutines. That's where you launch new coroutines from or into. And the dispatcher just basically says on which thread the coroutines will run by default. And in this case, this will be the main thread. Alright, once I've got this coroutine scope, I go here and inside set on click listener, right? Whenever this button is clicked, I call to get reputation for user. I want to make this function suspending. And furthermore, let's say I want this to execute with context on a background thread. Therefore, I switch context to dispatchers.default. So great. And which part of that? This one. I don't want to have this toast right here. Remember, that's not idiomatic coroutines. So I want to just return something from this method. Suspend get reputation for user. This returns integer, that's the reputation. And from here, I want to return basically this reputation. I don't need that. I can just do it like this. Okay, beautiful. Now I have this get reputation for user as a suspending function, which means that I should use it from coroutine. And inside this suspending function, I call another suspending function, which switches the execution to a background thread. And therefore, all of that is executed on a background thread. And I return the result of this function call from this with context and then from this get reputation for user function. Back here, get reputation for user is now suspending. Remember, we have this sign for suspending functions, but my code will not compile because it says that I should call suspending function either from another suspending function or from a coroutine. So I want to launch a new coroutine, and for that I just do that, right? Coroutine scope launch, and then move all of that right into here. So val reputation equals that, and then I toast this reputation. Once again, whatever happens inside this suspending function, get reputation for user, the next line of code within coroutine scope, within coroutine block of code, will wait for this function call to return. Therefore, this toast will happen only after I complete this get reputation for user call. However, I should not accidentally make the same mistake that I already did. So let's grab these and put them inside the scope of this coroutine. So basically now what this coroutine does, I launch it, it immediately disables this button, fetches a reputation for this user, and then shows toast. And after all of that is done, only then will this coroutine enable this button back. Therefore, I will not be able to execute several of these flows simultaneously. I think this should do. Let me just run my application and see what's going on. Yes, of course, there's a problem. Okay, let's see. First of all, I have this exercise 1 fragment and something changed about it. And I didn't really want to change anything here. So what's the problem here? Exercise 1 solution fragment. Yeah, okay. So I want this exercise 1 fragment back to Screens Navigator. I want to import this one. But for the sake of the demonstration, well, let me just make the following. I did a bit of mess, so let's just see what's going on here. Git status. So I want git checkout, and basically I don't want to make any changes inside, well, either activity composition root or exercise 1 fragment. And you know what? I can even further go into my solutions package. So go into here, and I really don't need this get reputation endpoint here. I can just remove it. And therefore, inside these solutions, I want to use get reputation endpoint from exercise 1 itself. I really don't need to copy paste this class, and it will make things much simpler to keep it in one single place. Okay, now hopefully everything works, but I remind you that I don't have exercise 1 solution inside my application. So basically, if I run it, then I don't have here any exercise 1 solution. And I don't really want to add it because that will be just useless for you in the long term. So to make sure my solution works, I will go to Screens Navigator for just 1 second, and instead of showing exercise 1 fragment, I will show exercise 1 solution fragment. Now let's rerun the application. Go to exercise 1, and now this is exercise 1 solution, some user ID, click on get reputation, and you see that the button becomes disabled, and basically after 3 seconds I get this toast. And once again I will click on get reputation. Please note that this cursor, this blinking cursor, it is not stuck, and then I will click on this button and you will see that the keyboard is hidden. So get reputation, keyboard hidden, cursor is not stuck, and after 3 seconds we get this toast. So everything works exactly as it should work. I hope that you arrived at the same solution or a similar solution and your application works exactly like that. Alright, I hope you had fun working on exercise number 1, and now I want to proceed to the next topic in this course. So let me bring you back for a moment into this basic coroutines demo. So I start a benchmark, everything works as expected, right? The button is disabled, then I see this toast, and everything is absolutely great. However, there is just one single problem here. If I click on Start Benchmark and then put the application into background, let's wait for 5 seconds, and then boom, we see this toast. So what it means is that even though I put my application into background, there is still some process that is being executed, and my application, even though it's backgrounded, is still active. Now, there are some circumstances, special circumstances, when you will actually want to keep your application active when it's backgrounded. However, that's not the case in this simple tutorial application, and there are absolutely different ways to achieve that functionality. So in this case, the fact that I click on Start Benchmark and then background my application and there is still some process going on is actually a bug. And in this lecture, I want to fix this bug. Let me tell you right away that the topic of this lecture is cancellation of coroutines. To demonstrate you how to go about cancellation of coroutines, I created this coroutines cancellation demo fragment. Currently, this fragment is exactly equivalent to this basic coroutines demo fragment that I used a moment ago to demonstrate you the problem. So I want to fix that problem. Basically, I want to make sure that when my application is backgrounded, nothing is active in the user interface part of my app. To achieve this goal, I need to ensure that after onStop method of this coroutines cancellation demo fragment, so let me just introduce this method, override methods onStop, right? So after this method returns, I need to make sure that this fragment is kind of inactive, dead. There are no processes, no activity inside this fragment that can affect the user interface or any other aspect of my application, really. The user interface part, the presentation layer logic, and fragments are part of presentation layer, should be dead, should be inactive after onStop method returns. So that's what I want to achieve here. How do I go about it? Well, it's relatively simple, at least as far as you are not concerned with various edge cases. So one of the powers of coroutines is that it's kind of simple to cancel them. What do I mean by that? Well, when I use this launch coroutine builder, it actually returns an object of type job. So I can use that object to cancel this coroutine whenever I want. To do that, I will introduce another private var, let's call it job, of type job, Kotlin X coroutines job, yes, and this should be nullable, and initially it will be null. Okay, why do I need that to be nullable? Well, because it's not guaranteed that I will actually have this job. So here, whenever I launch this new coroutine, I will do the following. My job equals whatever it is that is returned from this launch builder, And using this job, and you can kind of think about jobs as handles to coroutines. So here I launch a coroutine, and to keep a reference, kind of keep a reference to that coroutine, I have this job object. So whenever I have this job object, in onStop, I can do the following. I can do if job is not null, then I want to cancel it. And that's really it. So once again, I have a job that I obtained from this launch coroutine builder. And then in onStop, if this job is not null, I cancel it. Let me show you how it works. I go to coroutines cancellation, click on start benchmark. The benchmark is started, put the application in background and wait for 5 seconds. Nothing happens. Absolutely nothing. Okay, once again, done. However, there will be a problem, and this start benchmark button, it is not restored to enabled condition. Why is that? Well, let's jump back into the source code. So what happens when I perform this job cancel call? Well, this coroutine that I have right here, that is running right now, will be cancelled. But what does it mean for a coroutine to be cancelled? If you know anything about asynchronous multi-threaded concurrent flows, you know that cancelling such a flow is actually a very tricky and nuanced thing to do. And in most cases, you will want to be very, very cautious when doing that. So what happens here? I just call this cancel, and then what exactly? Well, what happens is that this coroutine is cancelled. But for example, if I'm here inside this iteration, the cancel call will have no impact on this process, because there's no way a coroutine can just kill a running computation. So when this cancel takes effect, then, well, this cancel call will take effect either when I actually check this cancellation status of this coroutine and kind of cancel it manually. That's called collaborative cancellation. Or alternatively, when I use one of the suspending functions provided by the framework, and they also check this cancellation flag for me. So in instance, when I start this coroutine and enter this execute benchmark method, I enter into this with context dispatcher's default, and I start my benchmark. So as I already told you, if I cancel this coroutine at this point, it will not have any effect on the execution of this benchmark. So the benchmark will be executed and this log statement will be printed. I will show you this in a moment. So the next point when the framework will check the cancellation status is basically whenever I return from this with context call. So this with context function, which is provided by Coroutines framework itself, internally checks the cancellation status whenever it started and whenever it returns. In other words, if I cancel this coroutine, if this call happens before I start my coroutine, then this with context will not even execute anything. I will try to get into it and it will see that the coroutine is cancelled. Nothing of this benchmark will be executed. But if the coroutine already passed this point, so basically if this code started to execute, then it's guaranteed that it will execute to the end, and the cancellation status of the coroutine will be checked only when this with context completes. So basically when this method returns. And it's really very easy to demonstrate that. So let's get back to the application. So I go to coroutines cancellation and I will click on start benchmark and then put the application in background. But please note that I will put the application into background before this countdown completes. So basically I will execute this job cancel call before the benchmark completes. So 5, 4, 3, now I put that into background and the coroutine is cancelled. And the interesting question now is, when was it actually cancelled? Let's take a look in the logcat. I can see here a button callback on the main thread, and then update remaining time 5 seconds on the main thread, benchmark started on the main thread, and by the way, now I realize that I can make it much clearer. So here I will just add on stop, okay? On stop. I want to log this event. Let's rerun the application and I will show you what I mean. Once again, coroutines cancellation, start benchmark, wait for 3 seconds remaining, and put the application into background. Now let's see what we have in logcat. Here I have button callback on the main thread, then update remaining time 5 seconds, and then benchmark started on the background thread. We understand what happened so far. Then I have update remaining time 4, 3, 2, and here I have this on stop. And this on stop, this method, is called on the main thread, on the UI thread, and that's actually how all lifecycle methods in Android are called, so that's very natural. But then after this on stop, I still see update remaining time 1 second. So first of all, this method still kind of works, and then I also see this printout, benchmark completed on this worker thread. So I can actually see this printout. And that's exactly what I told you. The fact that I cancel this coroutine doesn't have an immediate impact on the execution. It will have an impact when this coroutine reaches the point when basically the framework checks for cancellation. Now, at this point in the course, I just want you to have some kind of an intuition about coroutines. Therefore, I will not show you how to actually cancel this coroutine during these iterations. Basically, there is a way to break out of this loop whenever cancellation occurs. I don't want to get into this topic right now, but I promise that we will deal with that later in the course. Currently, I am just satisfied that this coroutine is canceled eventually, and I don't print anything on the UI of my application. However, there's still a problem that if I get back to my application, basically I get back to this fragment, the button is disabled, and therefore I can't run this benchmark again. And the reason why the button is disabled is here, okay? I launch this coroutine, I disable the button, then I call to this execute benchmark method. And as I told you, I cancel this coroutine while this method executes, and therefore, whenever this method completes, basically whenever this with context completes, the coroutines framework cancels the coroutine, and therefore all this code that I have after this method will not be executed. And of course, part of this code is this statement which enables the button back. All in all, the reason this button is not enabled when I bring my application back into foreground is because this statement is not really executed if I cancel this coroutine. So how do I address this problem? Well, there is a way to address this problem coroutines way, let's call it proper way, but it will require me to introduce additional concepts, and I don't want to complicate the picture at this point. Therefore, I will just solve it quick and dirty right now. And that's not the way you should do it in your applications, but I just don't want to introduce all this complex stuff all at once. So I will just grab this statement, and whenever I actually cancel my coroutine, I will also enable this button back. And therefore, basically, each time on stop is called, this button is enabled. So this will do the trick in this case, and let me show you that it actually works. Again, go to coroutines cancellation, start benchmark, put the application in background, let's make sure that no toast is shown, and then get back to my app, and start benchmark button is enabled, so I can actually click on it. And it doesn't really matter when I get back to this button, to this screen. You see, even if I get back before the coroutine completes and I still see these printouts, this start benchmark works. Once again, let's go over this code. Whenever I call coroutine scope launch, whenever I use this launch coroutine builder, I get a reference to a job. So I can grab that reference and store it in a field. Then whenever onStop is called, I can cancel this job, well, if it's not null, surely, and then I use this ugly workaround, it's a hack, and I enable the button back. And why is that? Because I know that here I should enable this button. But if I cancel the coroutine and the coroutine is actually canceled, I can be absolutely sure that this has been called, but this line of code will not execute, and therefore my button will remain disabled forever. To work around that, I employed this ugly hack, and once again, you should never do anything like that in your own application. There is a proper way to handle this case with coroutines, but I feel that at this point it will be too early to get into that, so we will discuss it later in this course. The goal of this lecture was to just show you how you cancel coroutines, and as you already see, there is a little bit more nuance. Well, actually, it's not a little bit more nuance. Cancellation of asynchronous, multi-threaded concurrent flows is a very tricky concept. So even though it's very simple to call this job cancel method, there is quite a lot of complexity, additional complexity that you need to understand and take care of. And as I said, it's too early in the course to discuss the entire complexity of cancellation, so I will keep it at that kind of intuitive explanation, and we will of course discuss that in much more details later in the course. Now it's time for you to do exercise number 2. You can find the fragment corresponding to this exercise in exercises, exercise 2 package, exercise 2 fragment. Currently, this fragment is an exact copy of solutions exercise 1 solution fragment. Basically, it's the solution that I wrote for exercise 1, and I just copied it and changed its name. As you might remember, the functionality of this fragment is to basically show this edit text, allow the user to input some user ID, and then get reputation for that user, which will be displayed in a toast after 3 seconds. And once again, for example, I can get reputation, close the keyboard to see this toast. However, there is a problem with this fragment, and the problem is exactly the same that you saw in the previous lecture. Basically, if I get reputation and then put my application into background, I will still get this toast reputation 53. What it means is that even though I put the application into background, there's still some kind of a process that runs there, and this process affects the user interface of my application because, well, toasts are part of the user interface as well. So your goal in exercise number 2 is to make sure that whenever the application goes to background, there are no side effects in the user interface. And the way to achieve that is by canceling the running coroutine. So you will need to cancel this coroutine that is launched here, and you will do that in exactly the same manner as I did in the previous lecture. Once again, by this point in the course, you are not expected to understand all the nitty-gritty details of coroutines cancellation. Instead, what I ask you to do is pretty much to just copy-paste the code from a coroutines cancellation demonstration package into this exercise 2 fragment. Make sure that the coroutine is cancelled, and then also don't forget to make sure that whenever you bring the application back to foreground, the button is not disabled. And to do that, please use the same hacky approach that I demonstrated in the previous lecture. Now, let me show you once again how I suggest you to approach exercises in the context of Git. So when you just clone your repository, you will be on a master branch. And to work on exercises, I recommend that you create a new branch for each of them. So git checkout -b says create a new branch, and let's say that will be my exercise 2 branch. Okay, switch to a new branch, my exercise 2. Outstanding. On this branch, I'll do git log, and you will see many more commits than I see on my screen right now, because by the time you will clone this repository, the commits for this entire course will be contained in it. Currently, I'm just building this application, I'm just recording these lectures, So currently the last commit is this exercise 2, but for you this commit will be somewhere down the list. So you need to search for it, and once you find this exercise 2, by the way, if you use command line git, you can search inside commits history by using this slash and then just writing exercise, and it will find all these exercises, and you can then click on N button or P button to jump to the next or previous search occurrence. So once you find this commit exercise 2, you grab its SHA identifier, that's the unique identifier of this commit, and you do git reset --hard and then paste this SHA identifier. And you will get this message, head is now at this exercise 2 commit. Then once you're at this commit, go solve this exercise, do everything that you need to do, and then do git commit -m, and let's say my solution to exercise 2. Now in this case git tells me nothing to commit, working tree clean. That's reasonable because I didn't change any code, but you will change some code when you work on this exercise. So you will create a new commit on this new branch, and then you will have git branch. You will have master branch, potentially my exercise 1 if you decided to create a new branch for exercise 1, and then my exercise 2. So you will create this my exercise 2 branch, and it will contain this new commit. Then to get back to master branch, you do just git checkout master, and git will tell you switch to the branch master, and now you are back to the final state of the source code, and you can continue with this course. So I hope you will enjoy this exercise. It's not really difficult, it's a simple exercise, but once again, our goal here is for you to develop intuition about working with coroutines. And for that, exercise number 2 will be absolutely great. So good luck and have fun. In this lecture, I will show you my own solution to exercise 2. So let's go to solutions, create a new package here, call it exercise 2. Then grab this exercise 2 fragment, paste it here. Let's call it exercise 2 solution fragment. All right, exercise 2 solution fragment. And I remind you that my goal here is to cancel the coroutine to prevent this notification, this toast, from appearing after the application is backgrounded. Okay, how I do that? Well, very similarly to what I did in cancellation demonstration. Private var job of type job, but it should be nullable, and initialize it to null. Yes, import please. Then whenever I launch this new coroutine, I just assign the resulting job into this job field. And lastly, I don't have it right now, so let's add that. Override methods. I will override on stop, and whenever the application is stopped, well, whenever the fragment is stopped, not the application, because this might happen, for example, if I switch fragments. So whether I will show you in a second. So let's first of all job. Okay, if it's not null, then cancel it. And now let me show you what I meant. So let's go to screens navigator, and for just a split second, instead of exercise 2 fragment, I want to put here exercise 2 solution fragment. Okay, you know what? First of all, let me just cancel that, and I will run the application without the cancellation of this job. Once the application starts, I go to exercise 2, input some field, and click on get reputation, and then click on back. And what you will see is that boom, application crashed. Why is that? The reason for that crash is this illegal state exception fragment exercise 2 solution fragment not attached to a context, and it says here. So basically what happens, whenever I navigate back to the previous screen, this fragment will indeed be detached from the activity, from the enclosing activity. And therefore, when I come to show this toast, require context will result in a nullable reference and will throw an exception because require context should not return anything nullable. And in this case, I get this crash. And that's actually a very important demonstration, which shows that we don't just get non-optimal user experience if we don't cancel this coroutine, but we can actually get crashes of our application because, well, fragments are tricky, and in general, every time you don't kind of stop your fragments and activities, you don't make sure that they are kind of inactive after on stop, you might run into very serious bugs. Therefore, you should always aim to have your fragments, your activities, and other lifecycle aware components to be basically inactive after on stop. And that's why I added this job cancel. So let's run the application. Go to exercise 2, user ID, get reputation, go back, and we don't see a toast and we don't see crash. Once again, get reputation, close background the app, no toast, get back to the app. However, the problem here now is that this get reputation is not clickable, it is disabled. I can fix that if I just type one additional letter, but that's not optimal user experience, so I want to take care of that. Just to remind you that the problem here is that this line of code where I enable this button back is never called if I cancel this coroutine. And as I already told you, there is a proper way to handle this edge case. However, currently I'm not interested in explaining you how to do that because that will be too advanced at this point. So instead I will just go quick and dirty way and copy paste this piece of code right in the on stop. So what it says is that after you cancel the coroutine, please enable this button back. That's all. And if I run the application now, go to exercise 2, input something, get reputation, background the app, no toast, then get back to the application, and this get reputation is enabled again. So now it works as expected, even though inside the code I planted this ugly hack. So that's my solution to exercise number 2, and hopefully you arrived at something very similar. Alright, I hope you enjoyed working on the previous exercise, and now let's jump to the next topic. I created this Concurrent Coroutines package, and inside you have Concurrent Coroutines demo fragment. Currently, this fragment is an exact copy of Coroutines cancellation fragment. So there's nothing new, nothing that you haven't seen yet inside this fragment. That's your standard benchmark with a single button. Now, what I want to address in this lecture is this piece of code that resides inside update remaining time function. Let me show you one of the problems with this code. So run the application, and now I will go to this Concurrent Coroutines fragment, and then when I click on start benchmark, I will start seeing printouts. What I want you to notice is that when I put the application into background, I will still see this update remaining time function being called repeatedly after that. So start benchmark, go to background, 4, 3, 2, 1. Okay, so basically this function, it continues to work after the fragment is stopped. And as I already told you, that's a recipe for disaster. Therefore, what I want to do in this lecture is to fix this behavior. So first of all, what do I want to do? Well, I want to make sure that this update remaining time stops after the fragment is stopped. And there are multiple ways to do that, but maybe the simplest but the ugliest way is to do that. Lifecycle current state is at least started. And that. So I basically say that if the fragment is in started state and you have time, then do that. Otherwise, just print done. And then maybe I also want to move this printout inside this block of code, inside this if condition, such that when this is not executed, I will not see any more printouts. Let me test and see how it behaves now. So once again, go to Concurrent Coroutines, start benchmark, and then put it into background. And what you see is that onStop is called, and there are no update remaining time after that. So we saw 5, 4, 3, onStop, and boom, none. We still see this benchmark completed stuff, and this comes from here, from execute benchmark method. But as I already told you, disabling this iteration, disabling the benchmark, is a little bit more nuanced stuff, and I don't want to get into that at this point in the course. We will definitely discuss that in the future. So just ignore this last line of logcat. Currently, I achieved my goal, right? I basically canceled this update remaining time recursive calls whenever the fragment is stopped. However, this is really ugly. And it's ugly due to several reasons. The first reason is that this method is very complex, well, relatively complex. I have a lifecycle check here, and it's ugly, but the bigger problem really is that these types of checks, if you have them in their code, usually it means that there's some kind of uncertainty about what's going on, and you basically kind of fragment the handling of lifecycle. Okay, you would like to do all of that inside onStop. So basically, when you look at this onStop method, you immediately know what kind of actions you take to make this fragment stop. But if you have this check right here, then it means that part of that basically stopping the fragment, part of that logic already leaked into different places inside this code base. And this can be very ugly and can get out of hand really quickly. So that's one. Then we have this handler get main looper. First of all, that's ugly. You know, this post delayed and then recursive call to itself with a delay. That's ugly. But the bigger problem is that I started using coroutines inside this fragment, right? So for example, this execute benchmark function is called on the main thread from here, from this coroutine. But here I kind of fall back, I call to this update remaining time from within this suspending function, and inside this function, I kind of fall back to Android's legacy threading model. So this handler get main looper is something that we had in Android from the very early days, and it works. But once you start using coroutines, you don't want to use multiple approaches. You want to basically standardize the way you write your code. And in this case, I want to use coroutines for everything. Therefore, this piece of code is just, first of all, ugly once again. But the bigger problem is that future maintainers will not understand why I mix coroutines with this legacy approach. So my goal now is to refactor all of that to coroutines and get rid of the legacy code. Okay, first of all, I will make this function suspending, update remaining time, and then I can get rid of this check. You will understand in a moment why I don't need it anymore. Okay, remaining time seconds. Now I'll grab this, well, actually I will delete everything from here. No, you know what? I will not delete everything, step by step. I'll grab this, I will delete this handler, and paste this update remaining time. Basically, that's a recursive call to itself, right? But this call should happen only after 1 second. So I need to somehow introduce a delay of 1 second into the execution. So between these two lines of code and this one, there should be 1 second delay. And if I use coroutines, I actually have this delay function, and it does exactly what its name suggests. It delays the execution by 1 second. And the last piece of refactoring that I want to do inside this function is to get rid of this recursive call. It will work, but you know, there's really no need to complicate stuff. I can easily replace this recursive call with a simple for loop, so no need to complicate my code without a need. So for time in remaining time in seconds down to 0, right? put everything inside this for loop, and then I ask if remaining time seconds is greater than 0, but now I need to just replace everything with time. So time here, time here, time here, and I think that's all. Again, what this function does, it's a suspending function, so it must be called from either another suspending function or a coroutine, and very conveniently it is called from execute benchmark, which is suspending function, and we can see here this little sign that means suspending call. And inside this suspending function I have a simple loop that counts from remaining time seconds down to 0, and then if time is greater than 0 prints that sleeps for 1 second, delays execution for 1 second, and when time reaches 0 we just print done. This should work. Let's run it and actually test. Okay, concurrent coroutines, start benchmark. What I can see, 5, 4, 3, 2, 1, and then benchmark started, and now after 5 seconds I will see benchmark completed and a toast. So now instead of executing concurrently, my code starts to execute basically serially, right? I don't see concurrency anymore. What I see here is that this update remaining time is executed, and only then the benchmark is started. And actually that's not surprising. Recall that we discussed that maybe the most important feature of coroutines is that whenever I make a suspending call, like I do here, update remaining time, the execution will be delayed. The execution of the next piece of code, which is this, will be delayed until update remaining time, until suspending function returns. So this function in this loop performs all that, and it takes 5 seconds, and only after this function returns, update remaining time returns, only then I will proceed to executing the benchmark. So this code works exactly as you'd expect it to work based on the coroutines mechanics, but that's not the way I actually want it to work, because I want to achieve concurrency. I want to print the remaining time concurrently with the execution of the benchmark. So how can I address this problem? Well, the easiest way is to launch multiple coroutines concurrently. So I will go here, and before I launch this benchmark, I will do the following: coroutine scope launch, and inside this scope I will actually do that. I will launch this suspending function. Now let's put this benchmark duration in seconds here, and then pass it into our benchmark method. Yep, add it as a parameter. So execute benchmark receives this benchmark duration seconds as a parameter now, and update remaining time is a suspending function, and it is called from a standalone coroutine. So I have one coroutine and another one. And by the way, after that, if I have this execute benchmark and all it does is calling with context, then I can simplify it to just basically this, okay? And maybe remove one of these. Great, so execute benchmark is a suspending function which is responsible for executing the benchmark, and update remaining time is a suspending function which is responsible for updating the remaining time, of course. And now my code actually looks much better than before. I promised you that I will get rid from a call to update remaining time from within execute benchmark, and as you see, I delivered on this promise. I really needed it to be here to show you basically the sequential nature of suspending calls within a single coroutine. All right, but said all that, I still haven't shown you that this code actually works. So let's run the app and go to concurrent coroutines, start benchmark, and we see 5 thread benchmark started, countdown, and immediately with done, we see this benchmark completed, and there was a toast. Let me show you once again: 5, 4, 3, 2, 1, and a toast. Boom, done. Okay, so now it actually works, but there's just one single problem. If I do start benchmark and then put my app in background, I can still see this update remaining time, 3, 2, 1. And that's something that I didn't want to have. Remember, I already fixed that with the legacy approach, but now I need to fix this with coroutines. And the way to do that is exactly like here. I just need to cancel this coroutine in unstop. Okay, how do I do that? Let's create another one of these. So this will be job counter, let's say, and then job counter equals that. Go here and just do, okay, job counter cancel. Great, let's run the app. And again, concurrent coroutines, start benchmark, put it in background, and boom, on stop, and no printouts, except for this one, but I already told you, just ignore it for now. I promise you we will take care of that. But update remaining time, this function, it is stopped. Basically the coroutine is cancelled, so I don't see these printouts anymore. But there is still a little bit of problem here. If I get back to my screen, I can see 3 seconds remaining instead of done. And the reason why I see 3 seconds remaining is because, well, I actually cancel this coroutine, right? I cancel this coroutine in on stop, and then this update remaining time at some point just stops executing. And when it stops executing, it really stops. So this line of code, if I cancel this coroutine, this line of code will not be executed, and therefore I will not see this done printed. And there are multiple ways to fix that. And of course, as I already told you, we will deal with cancellation a lot in this course. There is a proper way to work with cancellation of coroutines, but currently I just want to, quick and dirty, make it work. So I will just copy paste this line of code right here. How dirty is that? Very, very dirty. Let's run the app. Concurrent coroutines, start benchmark, far 4, 3, okay, get back here, done. Everything is great, but there's just one single problem. If I go to concurrent coroutines, and I don't start benchmark, but put the app into background and then get back here, I can still see done. But I haven't started benchmark even. Why I see done? Well, because this line of code is executed anyway. So maybe I want to do something like that. I want to do apply here and then just move both of these inside this block of code. And in other words, I just say, okay, if job counter has ever been started, then cancel it and show done. If not, if I haven't started the counter, well, if I haven't started the benchmark yet, then no need to do any of that. And lastly, let's run the app. Go to concurrent coroutines, start benchmark. We can see these printouts. Let's make sure that it actually shows the toast at the end. Yes, we can see this toast. Start benchmark, go to background, boom, on stop, nothing is printed except for benchmark completed. That's okay. And done. And let's maybe go start benchmark, go to background, bring it back, and we don't see anything here. So now at this point, after all this hackery, my code works as expected. Let's go over what I did once again. This function, update remaining time, used to be just a regular function, and inside I use this handler get main looper stuff, which is legacy approach to managing UI thread in Android. Now, since I use coroutines, I refactor this function to be suspending function. So now it's actually part of coroutines, let's call it lifecycle. And here I use this delay call to delay the execution by 1 second. And this allowed me very simply to refactor the recursive call to a standard for loop. So the code became much less complicated than it used to be. Very simple code actually. But since I use coroutines, I had to somehow cancel this stuff. And therefore here, when I launch it in new coroutines, and by the way, I need to launch a new coroutine. Basically, I need to launch 2 concurrent coroutines, because if I just put this update remaining time into execute benchmark, then first of all, that function will be executed fully, and only then we will proceed to the benchmark. That's not what I want. So I had to use two concurrent coroutines. This one is responsible for printing the remaining time. This one is responsible for the benchmark, of course. All right, so I need to cancel this coroutine because, well, I want to cancel these printouts when the fragment is stopped. So in unstop, I cancel it. And also I show this done label if this counter has actually been launched before. All right, that's it. All in all, in this lecture, I got rid of legacy handler looper Android approach to threading and refactored this entire fragment to use coroutines appropriately. Well, except for maybe this ugliness inside onStop, but as I told you, we will take care of that later. And also, I don't actually cancel my benchmark when this coroutine is cancelled. Basically, my benchmark will execute to the end and only then it will be cancelled. And we will take care of that later in this course as well. Now, I feel that this lecture was a bigger jump in complexity than the previous lectures. So if you feel that you don't quite understand what I did, then just go back and watch this lecture again. It will all become very clear and very evident. There is no shame in going back when we deal with coroutines. Nothing of that is really simple. In the previous lecture, I demonstrated how to launch several concurrent coroutines here in this Concurrent Coroutines demo fragment. And to be honest, I made it look very natural and very simple, but in fact, there was something really interesting that I kind of glossed over. And the reason why I did that was because I didn't want to pack too much information into one single lecture. So in this lecture, I want to actually address that point. Okay, what am I talking about? So if I go to update remaining time function, I can see that it calls this delay method. And as you saw, this delay delays the execution of the code by 1 second, and therefore we print this seconds remaining every other second. Okay, that's cool, but that's not trivial at all. Let's get back here. Here I launch one coroutine and it's launched on the main dispatcher, right? Dispatcher's main immediate. So it kind of executes on UI thread. And then I launch another coroutine and it also uses main dispatcher. So it's also executed on the UI thread. And yes, here inside execute benchmark, I switched to another dispatcher, but originally when this coroutine is just started, it's all on UI thread. And this first coroutine, even though it executes on a UI thread exclusively and delays for 1 second, basically waits for 5 seconds, right? It's 5 seconds and every time it delays by 1 second. Even though this happens on UI thread, this thread is not blocked. Let me show you the difference between blocking and what this delay suspending call does. So as you might know, whenever I use threads in Java, for example, I can do this thread.sleep and then put a sleep timeout of 1 second here. And immediately Android Studio gives me this warning, inappropriate blocking method call. You will understand why it warns me this way in a moment. So I put this thread sleep, and sleep is very similar to delay. I just want to delay the execution of the next statement within this function by 1 second. However, this will lead to a major change in the functionality of my app. Let me demonstrate you that. Once again, I go to Concurrent Coroutines fragment, and when I will click on Start Benchmark, please note several things. First of all, this button will become stuck. And in addition, in the logcat, I will start seeing these printouts, update remaining time, blah, blah, blah. However, I will not see that the benchmark is started. And then only after 5 printouts, I will see that the benchmark is started. And in addition, I will also get a warning from Android Studio that my application skips frames. Let me show you that. Start benchmark, the button is stuck. Now I see this update remaining time, okay, 0. And then I see benchmark started. Okay, so I see benchmark started, but before benchmark started, I saw this skipped 301 frames. The application may be doing too much work on its main thread. And then benchmark completed. So basically what I did here by adding this thread sleep statement, I kind of made the execution sequential once again. So even though I launch two coroutines here, they are not really executed concurrently. This piece of code, this suspending function, is executed, and only then this coroutine is launched and the code within this coroutine is executed. What's the problem here? Well, as we already discussed, this suspend modifier, the fact that this function is suspending, doesn't really do anything important here. It simply instructs the compiler to check to verify that this function will be called either from another suspending function or from a new coroutine. That's all, and this function is not any kind of a special function. Therefore, when I call this thread sleep for 1 second, what I effectively do is sending my main UI thread to sleep for 1 second, and a sleeping thread doesn't actually do anything. So I start this loop, and then within this loop, I send my main thread to sleep for 5 seconds. In other words, the main UI thread of my application is stuck inside this update remaining time function for 5 seconds due to this loop and this thread sleep statement. And therefore, when I launch the second coroutine, it doesn't even start because it's on the UI thread. So basically, I'm stuck right here and nothing of this code is executed. Then at a later time, when the execution of this update remaining time method completes, the code proceeds to the next statement, which is this, and then we can see the benchmark. So that's not a good implementation, obviously, but it does demonstrate one very important difference between standard Java JVM, basically threads, and coroutines. Threads are blocking, coroutines are suspending. Blocking means that whenever I execute this thread sleep statement, the main UI thread or whatever thread called this update remaining time function, and in this case it's UI thread will be blocked, and blocked threads don't do anything. They can't do any more work, and therefore we see my application being stuck for 5 seconds. However, if I just replace this with delay of 1 second, and again delay is a suspending function, something magical happens. And the magic here is the fact that even though I delayed the execution by 1 second on main UI thread, this thread is not blocked. It can continue to the next statement, and in this case is the execution of another coroutine which is also launched on the main thread, and then I get concurrency on one single thread. And that's something that standard JVM threads cannot do out of the box. So that's a very big difference between coroutines and threads, that whenever I have delay, whenever I have suspending function, not only the execution of the next statement will wait for the completion of this function, but I can also kind of execute another code on the same thread that calls to this delay function under some special conditions. We will discuss these conditions in one of the future lectures, but for now it's just enough that you get a bit of intuitive feeling that suspending functions and coroutines are not exactly like threads. There is something you can do with coroutines and suspending functions which you can't, or at least you can't do simply with bare JVM threads. So that was something that I kind of glossed over in the previous lecture, but now hopefully you see that the fact that I launched two coroutines and both of them are launched on the main thread, and then the code inside these coroutines is executed concurrently, is not trivial at all. That's the magic of coroutines in action. So far in my kind of tutorial fragment, I launch two concurrent coroutines, this one and this one, then store their jobs inside variables and cancel them in onStop. This works, but there is a more efficient way to do that. To demonstrate you this way, I created this scope children cancellation demo fragment. That's exactly what I'm looking at right now. You might remember that I told you at the very beginning of this course that coroutine scope is kind of a box for coroutines, and that's why you need a scope to launch every new coroutine. Every coroutine will be associated with a scope. And since coroutine scope is kind of a box, we can perform actually operations on all the coroutines that are inside that box simultaneously. Let me show you what I mean. I can get rid of these two jobs, right? And then I don't need this anymore. However, even though I got rid of the jobs, the individual jobs of these coroutines, I still want to cancel them in on stop. To do that, I can use the scope. So I can write a coroutine scope dot context, coroutine context, and then cancel children. And that's it. After this call, all the coroutines that the scope kind of holds reference to will be cancelled. And that's great. So I can get rid of this, and I can get rid of this cancellation. But there will be a problem. See, this assignment, it is predicated on the fact that I can distinguish between two conditions. The first condition is before I launched my benchmark, and the second condition is after I launched it. In the previous configuration of this code, I relied on the nullability of this job counter to distinguish between these two conditions, but now I don't have job counter anymore. So what can I do? Well, once again, there is a proper way to address this thing, because remember, I need this statement here only because I cancel this coroutine. So it would be absolutely amazing if somehow I could put this statement right here inside the coroutine, or right next to it for that matter, but basically in the context of this coroutine. And it would make it very clear that I execute this assignment because I cancel this coroutine. And there is a way to do that, but currently I don't want to go down this rabbit hole. So currently I will just do something really ugly. Private var that has benchmark been started once, and that's false initially, so that's a boolean flag. And whenever I launch this benchmark, I just set it to true. Maybe even just let's take it from here and put it down here. Okay, so basically whenever the benchmark is started, I flip the value of this flag, and then here I can do the following. If has benchmark been started once, I can put all these conditions right here. So there is no problem to put that inside this condition, and this will even make it more explicit. So it's now clear that these two assignments have something to do with starting the benchmark at least once. And if the benchmark hasn't been started, then I don't need to restore the button to be enabled, and I don't need to assign this text, to show this text on the screen. Alright, after I did that, let's make sure that the application actually works. Scroll down to Scope Children Cancellation, click on Start Benchmark. I can see the printouts, put the application in background, on stop is called, and then the only thing that is printed is that benchmark completed. No more printouts of update remaining time. So the application works in exactly the same manner as it used to, and this call, coroutine scope, coroutine context, cancel children, actually canceled both of these coroutines for me. So that's great, and that's actually the proper way to cancel your coroutines. Every time you want to make sure that there is no activity after a certain point, you shouldn't deal with individual coroutines, even if you have just one of them. Remember, you might have more in the future, and you wouldn't like to plant this time bomb. So instead of that, you just go directly to coroutine scope and cancel all its children. It's that simple. Now it's your turn to work a bit, so welcome to exercise number 3. You can find this exercise in Exercises, Exercise 3, Exercise 3 fragment. Currently, this fragment is exactly my solution to Exercise 2, so Exercise 2 solution fragment. I just copy-pasted it and renamed some things. Now, your goal in exercise number 3 is to do the following. Let me remind you before that what this fragment does is it has a button, And when you click on this button, it starts this get reputation for user flow and then shows a toast. Your goal in exercise number 3 is to show the elapsed time, the time it takes for this flow to complete. The actual UI element in which you will show this time is already here, so I added it for you. TXT elapsed time is a text view, and that's where you should show this time. Now, please note that it's a bit different from what we did before, because, for example, if I go to scoped children constellation fragment, right, that's my demo, and here I also showed some kind of a time, but here I showed the countdown. I knew already ahead of time that this benchmark takes 5 seconds, and I just showed the countdown. Your goal in exercise number 3 is to show a little bit different information, is to show the elapsed time. Therefore, you should not assume anything about the duration, okay, of this call, get reputation endpoint, get reputation. Well, you know that it will take 3 seconds, right? Because that's what I wrote here, but pretend that you don't know about that. Pretend that it's a real network request and you want to understand how long will it take. So your goal in exercise number 3 is to use this txt elapsed time to show how long, let's say in seconds, but if you want to challenge yourself, you can show shorter periods of time. So your goal is to show how long does this call take to complete. Now, this exercise will be a bit more challenging than other exercises because, first of all, you will need to add one additional concurrent coroutine, and then you will need to cancel these coroutines in onStop and make sure that there are no edge cases. And in addition, you will need to somehow cancel that additional coroutine when this coroutine completes, when this get reputation for user flow completes. Again, you should not assume that you know how long it will take. Therefore, whenever this flow completes, in addition to showing a toast and enabling this button back, you will also need to cancel that additional coroutine that you are going to add in this exercise. In other words, you will need to use 2 cancellation methods at once. In onStop, I would like you to use the cancellation through coroutine scope. Where's that? Through coroutine scope. But here inside this coroutine, when this flow completes, you will still need to cancel individual single coroutine. Therefore, you will also need to use job cancellation. That's why this exercise is a little bit more challenging than the previous exercises, but I'm absolutely confident that you can manage that. Now, I will not show you how to do this exercise Git-wise. If you need a reminder, just go to one of the previous exercises and see what I propose to do there. I recommend that you use the same flow, but, well, evidently you will need to reset your local branch to exercise 3 and not one of the previous commits. So that's a little bit more challenging and much more interesting exercise. I wish you good luck and have fun with it. Okay, let me show you my solution to exercise 3. First of all, let's create a new package for that solution. Exercise 3, yep. And then I will just go and copy paste exercise 3 fragment, exercise 3 solution fragment. Okay, here in this exercise 3 solution fragment, I will add my changes. Okay, I remind you that the goal of exercise 3 is to add elapsed time counter whenever this get reputation for user flow is executed. No problem, let's go here and right away launch a new coroutine. Coroutine scope, launch. And the reason why I want to launch new coroutine, of course, is because that counter should run concurrently with this get reputation for the user flow. And inside this coroutine, I will call new method, let's call it update elapsed time. Create function update elapsed time, and let's make it suspended function right away. Great. What do I write inside this function? Well, first of all, I will need to somehow count the elapsed time. And to do that, let's just create a new val of type start time nano equals system what that system.nanotime. So that's my start time, and then I need a loop. What will be the stopping condition for that loop? Well, there will be none. So that's while true. That's an infinite loop, and the reason why I am comfortable having an infinite loop here will become clear in a moment. So inside this loop, what do I do? Well, first of all, I need to delay the execution by how much? Let's say 1 second, and then I want to say the following. Let's say val elapsed time nano equals system.nanotime minus start time nano, and then I want to basically txt elapsed time text equals elapsed time, and then I will need to show elapsed time, and I don't want to show elapsed time in nanoseconds. That will be too much. So let's say val elapsed time milliseconds, or let's say millisecond, equals elapsed time nano divided by 1 million, and that's elapsed time, and then elapsed time milliseconds. So every other second I will wait for a second, and then I will show elapsed time in milliseconds. And I actually don't want to do that just every second, because that's too little of a period of time. Let's say that I will do that every 100 milliseconds, and this way hopefully I will be just able to see this counter running in kind of real time for me. Okay, I think this should work, but I still have some problems. First of all, whenever this fragment is stopped, I want to make sure that this coroutine is also stopped. So this flow is stopped basically by canceling this coroutine, but this new coroutine is not cancelled anywhere. So I want to cancel it, but instead of creating a new job for it, I will actually just remove this job. Okay, I don't need it anymore. And then instead of canceling individual job, I will just cancel the entire scope. Cancel children. Yes, like this. Okay, and the second problem that I need to address is the fact that whenever this flow is completed, whenever this get reputation for user flow terminates, I show the toast, I enable the button back, but my counter, elapsed time counter, will continue to run. That's not something that I want. I want it to stop at this point. Therefore, let's say I want to cancel this coroutine as well. And to do that, I will need this job back. So let's have it here, maybe here, private var job counter, let's say elapsed time of type job, and it will be nullable because initially it will be null, and then I will do job elapsed time equals this job. And then here inside the second coroutine that actually executes this flow, I will do job elapsed time, if not null, then cancel. And this will make sure that whenever this flow completes and I show the toast, I also cancel this job, and therefore my counter will just stop. Okay, at this point I think I can test this implementation and see if there are any bugs. But before that, I will just need to jump into Screens Navigator and for a split second replace that with exercise 3 solution fragment. Let's run that and see what's going on. Okay, scroll down, exercise 3, that's my solution fragment. Let me just input something here and then click on Get Reputation. If everything is correct, then I should see a counter here. Get Reputation, and I see the counter. And boom, this flow took almost 3 seconds, and the reason why it's almost 3 seconds and not exactly 3 seconds is because there are various inaccuracies here. So for example, if I go into this get reputation endpoint, get reputation, this thread sleep is not an accurate call. So the thread can sleep a little bit longer than 3 seconds, a little bit shorter than 3 seconds, and then there are all kinds of losses, basically time offsets that might happen here and there. So that's actually okay. this kind of accuracy is more than enough for this demonstration. So let's run this once again, make sure that we also see this toast down here. Yep, and I can basically go back, return, and let's just make sure that, you know, if I start this flow and then go back, when I return to my app, yep, we see elapsed time stopped at some value. Okay, everything seems to work, and that's the way I would approach solving this exercise. Hopefully you arrived at something very similar, but even if you use a different approach, but your solution works similarly to mine, that's totally fine. There is more than one way to skin a cat, and as our exercises will become more and more complex, there will be just many more options to solve them. So if your solution works just like mine, but is different on the level of the source code, that's totally fine. Okay, by this point in the course, you acquired quite a bit of intuition about coroutines, and in this lecture, I would like to summarize everything that we have discussed so far. Okay, first of all, we discussed this new concept, a coroutine. A coroutine is basically an abstract construct representing a sequence of steps. So you can think of it as a flow. Coroutine is kind of a flow. And one of the characteristics of this flow is that steps within a coroutine execute sequentially. That's not something special because most of our code executes sequentially. What's special about coroutines is that even though steps within a coroutine execute sequentially, they are not constrained to one single coroutine dispatcher. So basically, steps within a coroutine can execute on different coroutine dispatchers. What does it mean that they can execute on different coroutine dispatchers? Well, let's discuss coroutine dispatchers then. Coroutine dispatcher is basically an entity that executes coroutine's step on a specific thread or group of threads. So whenever you execute a coroutine's step, let's say one statement, you can execute it on a specific coroutine dispatcher, and behind the scenes, that coroutine dispatcher will route the execution to one specific thread or a group of threads. Now, a single coroutine can use multiple coroutine dispatchers. And you have seen that as well when we started a coroutine on a main dispatcher, and then somewhere along the execution of a coroutine, I use this with context function and switch to a different dispatcher's default, and then I could even switch back to main dispatcher if I needed to. And all of that happened within the context of a single coroutine where all the steps executed sequentially. And next thing I can say about dispatchers is that we have this dispatchers main, which is a special coroutine dispatcher corresponding to UI thread in Android applications. So that's not something you will find, for example, in backend applications, because in backend there is no main thread, there's no UI thread, but in Android, UI thread is the most important thread. And to access UI thread in the context of Kotlin Coroutines, we use this special dispatchers main in Android. The next concept that we touched upon was suspending function. That's actually a very central, a core concept in coroutines framework. So suspending function is a special type of function which can only be invoked within a coroutine. And it means that either we invoke it directly within a coroutine, or that a suspending function will be called by another suspending function. And that's basically the same thing, because if you can launch a suspending function only within the scope of another suspending function, and you continue to go up and up and up, then somewhere you will reach a point where the top level suspending function will be launched within a coroutine. So all suspending functions will run within coroutines. That's something that will be enforced by the compiler. Now, parent coroutine, the coroutine that contains the suspending function, will wait for suspending function to complete before proceeding to the next step. And that's very interesting and important feature in coroutines framework. So even if you start your coroutine, let's say on main thread, UI thread, and then along the way you switch to default dispatcher, basically switch to a background thread execution, Still, whatever happens after this background execution, all of that will wait for these background steps to complete the execution. So that's very important property. And suspending functions, that's another important property of Coroutines, is that suspending functions can suspend the execution, entering waiting state, but without blocking the calling thread. And what it means is that you can execute something like delay suspending function on a main thread, delaying the execution on the main thread by, let's say, 1 second, as I did in the demonstration, but still main thread is not blocked, and whenever that suspending function suspends, main thread can then go and execute other tasks. This property is very special to coroutines, and that's basically one of the core components, core features of coroutines framework. We will discuss that in much more details in the future lectures. And after we discussed suspending functions, let's discuss coroutine jobs, or just job. So each coroutine is associated with a job. Whenever you launch a new coroutine, you get a reference to a job. You can use it or not, but you get one. Coroutine's job is cancelable. You can just call cancel on a job, and that cancellation of coroutine's job will also cancel the coroutine itself. So that's the way you cancel coroutines. However, as you saw, when you have multiple coroutines, and in general, when you want to make sure that some of your companies is inactive after a certain point in time or in execution, you don't deal with individual jobs, you go directly to coroutine scope. What's coroutine scope? Well, coroutine scope is kind of a box that contains launched coroutines. So you launch a coroutine and you must associate a coroutine with some coroutine scope. And you can, of course, launch more than one coroutine within a scope at any instant of time. So this just basically says that you can have multiple concurrent coroutines within one single scope. And then very conveniently, since coroutine scope kind of holds the coroutines that you launched within that scope, you can just go and cancel all scope's children at the same time. You can basically cancel all of them regardless of how many there are. And that's actually very convenient because you can use this functionality to ensure that no coroutine by accident remains active after a certain point of time, for example, after a fragment is stopped. That's very handy. Now, all in all, with the intuition that you have right now after basically watching all this lecture and solving all these exercises, you can use coroutines inside your projects to implement simple concurrent flows. And in fact, many developers out there use coroutines when all they understand is what you know right now. So basically, this kind of intuition is already enough to start using coroutines, and factually, you have already solved several exercises, so you know how to use coroutines. However, I wouldn't recommend doing that. Why this intuition is not enough, in my opinion? Well, it's because we haven't discussed the following topics. We haven't discussed detailed cancellation mechanics and error handling and parallel decomposition. That's basically when you have multiple concurrent flows and you kind of want to bring them at some point together. And we haven't discussed structured concurrency. That's a very important piece of Coroutines framework. You hear about that a lot, but most developers don't have a clue what structured concurrency is and why it is useful. And of course, there are more topics that we haven't covered yet and you haven't practiced with more advanced exercises. So that's why I recommend that you don't start using coroutines in your production code with just this intuitive understanding of the framework. You can do that, many developers do that, but you will run into some serious issues down the road. And concurrency bugs, I remind you, are among the most complex, the most time-consuming bugs to find and fix in your code. So, in my opinion, the best course of actions for you right now will be to stick to the lectures, because in the next lectures we will discuss all of these more advanced topics and you will gain very rigorous, very detailed understanding of Coroutines framework, and at that point you will be able to use Coroutines framework not to just write code, but to actually write a robust code and not deal with concurrency bugs down the road. So, see you in the next lectures then.